Good morning, Tamina Khan is here in TKMaths is Fun. In today's video, we will see the concept algebraic identities and factorization, which is a part of the topic algebraic manipulation. And this topic is a part of the syllabus of O-level mathematics. You can see here my blog address and my website address for all the videos. And before showing you what is the requirement of this syllabus for this topic, I just want to show you here my blog address, website address. I have list down all the topics of the subject here, in the challenging question heading. And if you click on any, you will see the videos made in it. So this is a very good resource to have a quick recap of all the topics of the syllabus. It is still under development stage, but every day I upload videos in it. So similarly on the blog side, I have listed down all the topics and the videos I have uploaded. So both are good resource and you can have a good recap and revision from these sites. So let's see what is the requirement of the syllabus for the topic algebraic manipulation. So this is basically about factorization and handling of simplification of algebraic expressions which are given in this form, how to open bracket and expand them, things like that. So the question I have taken for this video are from identities and factorization, but little different type of factorization. So you can see how it is applied in questions in a different way. So you need to recall these three algebraic identities first of all, because we will make use of these in the questions. So I hope you know about these algebraic identities. So let's see. Without using a calculator, evaluate each of the following. When question says without using a calculator, it means you have to show the working here, right? Some people straight away do 102 multiply by 102. But if question says use algebraic identities method to expand it or to solve it or to find the value of it, then what will you do? So the thing here is 102 can be written as 100 plus 2 and whole square. Now this has become equal to identity a plus b whole square, right? I told you the formula here. So I will apply this formula here. This is my a and this is my b now. So I will simply apply the formula of this is like a square plus 2ab plus b square. Simple, right? And then this calculation is very easy. Everybody can do it mentally and you can add up and get the answer quickly, right? So another question is find out 497 square. Now how you will use algebraic identity to solve this question. And this comes with practice only, right? There is no fixed formula for that. So you can write it as 500 minus 3 because that is equivalent to 497. 500 minus 3 square. So this will take the shape of the identity, which is a minus b whole square. So it is equivalent to that. So we know the formula here, same formula but with minus sign here. So now I will expand it using that formula. So it will be like a square minus 2ab plus b square. If I'm considering this as my a and this as my b, right? After that, you can do it mentally. And then, of course, this is so simple. In O level and A level, we can easily handle these questions. Now, the last part, if the question is given like this, so rather than actually going through the multiplication method, which we learn in class 5 or 4, you will apply, for example, algebraic identity. Because if examiner mean to use algebraic identity, he will bound you by the wordings. So 201 can be written as 200 plus 1 and 199 can be written as 200 minus 1. Now, the moment you look at this, it reminds you the algebraic identities which says a plus b, a minus b. And you know what it is equivalent to? A square minus b square. So suppose this is my a, this is my b. So a square minus b square. So after that, it is very simple. You can calculate it now without a calculator, right? So these are very particular type of questions which are asked in the past paper with respect to algebraic identities. Now, there are another two very important questions. Now, look at this question. You have to find the value of x minus y whole square. And the information given to you is x square plus y square equals to 80 and x times y equals to 12. So what comes in your mind? So if you look at these questions, x minus y whole square, and apply the identity here, right? So this is equivalent to x square minus 2xy plus y square, the formula. So if you write these two together, x square plus y square, right, and minus 2xy here, so we know what is this equivalent to. It's given in the question, 80. And xy is equivalent to 12. So you can write down the values here and simple calculation after that. So it is equals to 56, right? So a question similar to this is here. Now, can you think what will you do here? You have to find the value of this. Does it remind you any identity? Yes, the third identity. So it is equivalent to x plus y, x minus y, right? We have to find the value of this. Now x plus y is given to you 10 and x minus y is given to you 4. So you just substitute the values and it is equals to 40. So this is how you will handle these type of questions. Now let's see the last type of questions here, which is again like third identity, a square minus b square. But the thing is, when the term is not a single term, rather it is two term, that simply confuses the students most of the time. So first of all, you have to recognize that this is the question which will be handled by this identity. Now, how will I take here a square? 25 can be written as 5 square. So it is 5m whole square. So this is my a and this whole is my b. Now, if you know, this formula is actually what? A plus b, a minus b, right? And your a is 5m and your b is n minus 1. So you will substitute in place of a and b. But you need to be very careful. Why? Because there are two terms and there will be minus outside here. So you see, I'm just simply applying in this formula. In this case, my a is 5m and my b is n minus 1. That's why I've used different color here. So now this is your factorization. Okay. Now another question in which you have four terms. Whenever you have expansion, factorization for four terms, you make pairs. So before making pairs, you see if there is something common you need to take out. So I can see 5 is common throughout. So I can take 5 common out. After that, I can make pairs. And then I will see what is common in it. Now see here. From here, x was common. So y minus 5x. This plus sign will come as it is. So what is common here? 2. So 2 5s are 10x, 5x minus y. So now if you see here in this one and this one, it seems 5x minus y common, but it is flipped otherwise. Now again, you need to recall here, if you want to flip a number which is, has plus in between, you can simply write like this. But when there is minus sign, you cannot simply do like that. You have to write minus outside, because if you open the bracket, you will get this term. So now to take common out, for example, I write here 5 minus xy, then I need to take minus outside. Or if I flip this one, I can write 5x minus y, then I need to write minus y, minus sign outside. So choice is yours. So in this case, we have flipped this one, y minus 5x, and minus sign has come out. Minus times plus is minus. Now I can see y minus 5x is common, so I've taken out. And x minus 2 is from here. Simple factorization. So this is the step. So thank you very much for watching this video. Please press like and subscribe button and share it with your friends. Thank you. Take care.